Made it. Okay. Sorry, everyone. We had a few technical difficulties at the beginning, but we are very much here and live with you now. Hey, welcome. This is the weekly Fairground or Testnet Jam. My name is Daigan. I'm a community manager at Vega, and you probably see me here and around Discord. I was hanging around there today, and also on Telegram every now and then. So what is this? It's an ongoing series, and it takes place every Thursday at 6 p.m. British Summer Time or UTC+1. And each week we take a deep dive into a different aspect of the Vega Protocol with a member of the Vega team or a special guest. And then we follow up with an open Zoom room. So if any of you are particularly keen to have a chat with the team or just to come and hang out with us, and then you're free to do so. So this week we have a return guest, but in a different format, very much original team member. We have blockchain researcher Klaus, and Klaus will introduce himself soon, but he's given you a nice wave. And today, Klaus and I will be talking about his involvement in the research that powers the big features of Vega, particularly around fairness, front running, anti-whaling, and many other things that he has written papers on. I also recommend you check out his research papers on our publication side of the Vega website, and you'll be quite, I think, impressed by the amount of stuff he's written in the blockchain space and also on the particular things that go into Vega. So we'll cover his current projects and also life before Vega, and you'll see the rest as we get into the interview. As always, some quick rules before we begin. Whilst Klaus is presenting, you're free to ask questions in the Zoom, in the Twitch chat, and he will answer those at the end of the call. About 5 minutes before we end, I'll post the Zoom link in the Twitch chat, and we encourage you to come along. Not surprise, but funny thing. If you sign up to the regular calendar invite each week, you actually will have the link to the Zoom room, so you don't have to wait for me to post it in the Twitch chat. That's some trivia for you. Yeah. Anyway, let's begin. So, Klaus, can you quickly introduce yourself?
Well, first, thanks for this nice introduction. So, yep, I'm Klaus, working in Vega on blockchain research, which I've done before in my life many years ago, with then some interruption because back then nobody cares. And right now, sitting in Geneva and waiting for finally being allowed to go out again and do stuff. And yeah,
very modest. Yeah, very modest, very short summary of the stuff you've been up to. So tell us, what did you do before working at Vega? And also, I think some good trivia would be, when did you first start researching either blockchain systems or consensus algorithms or different ways of agreement? Yeah, what did you do before Vega? And when did you first start getting into this industry?
So first, get into this industry was actually first relevant thing I did after studying. That was my PhD in '98, and I wouldn't call it that industry back then. Back then it was a research topic called consensus research. There was no blockchain back then, so our work was essentially thinking of distributing internet services like the DNS service. But we even were thinking so far of building the big internet computer that can do arbitrary things in a distributed way, sort of similar what Dfinity is trying to do now. And my work was essentially back then on asynchronous consensus. There were a couple of protocols, but none that would work in practice. So in parallel, Castro and Liskov came out with their BFT protocol. And we worked on a fully asynchronous, so no timing assumption protocol for Byzantine agreement, and then in the end ordering protocols, which is pretty much the same as a blockchain is. And I finished my PhD on this in 2001. We had a very nice protocol. We implemented it twice. So I did a prototype implementation, and then some people that know a bit more about coding did the real stuff. Got an EU award even. It was an EU-funded project, so we were second best project of that bunch, and then nobody cared. So we were going around shopping, and that was still with the full might of IBM behind us, and everybody said, yeah, but you don't solve a new problem, you can do what we already do in a better way, but we do it already, so we're not willing to invest a lot of money to do it differently. So we had a really hard time selling it. So at some point I decided to switch topics, went into secure hardware, started with trusted computing, which was a lot of fun since that was also the time of the Trusted Computing Conspiracy series. I don't know if you heard about those.
No, but you can give us a few, I guess.
So
and before that, you said nobody cared about the project that the protocol you'd worked on. What were the specific reasons that they said? You said there was something about a problem not being solved, but why did they not care at that time?
Well, I think that is sort of, for me, the really big thing that Bitcoin brought into the world, rather than the technology, is Bitcoin builds a business model. So when it started, I could be a Bitcoin miner, and in the beginning, I can do this on my PC every Saturday from 5 to 7, and I still make some meaningless Bitcoins, but it's also no effort, so fine. And the effort to be a miner in Bitcoin increased with the value. So it built a beautiful way to ease people into the whole distributed systems are cool stuff. In the approach that we had without this business model, there were some people that did care, which was more the fault tolerance people. So there were some platforms that are more used in settings like flight control systems or aircraft or some military ships. They were actually interested in, yeah, we want to distribute our control systems. But on a large scale, hey, let's build a distributed app infrastructure. We have the centralized thing, it works. We built good firewalls, so people didn't see enough value in distributing it to justify the effort and the cost to build the whole infrastructure. And also there was no validator infrastructure, obviously, back then, so you would have to run your validators yourself. So there were some special applications where people said, this sounds good, but it didn't have the large scale, oh yeah, we want to implement this now and we're willing to spend the money that's required to fully build it.
Yeah, you need some momentum
but
for decentralized systems.
Sorry, say again?
I think you need some momentum for decentralized systems, and that's what Bitcoin brought. You need a community. You need
and now that momentum is there, and now everything works, and all the old solutions are dug up. And yeah, so I changed topic, worked on trusted computing for a while. That was then also the time where people claimed trusted computing is so they will take over all of our computers. So there was then rumors that this chip, if they didn't like you, would place child pornography on your computer and they would arrest you. So that was actually the first time I ended up on internet forums where people discussed murdering people like me. So first time I was on the wrong side of a conspiracy theory.
That's crazy.
Which was an interesting time.
Were you targeted particularly?
No.
Or just the people researching?
There was just random discussions. We should go to the meetings of the standard and kill them all before they take over the world. And honestly, also on our side, so that was the other fun experience from being on the wrong side of a conspiracy theory. If it hits you by surprise, you just don't know what to do. We were a bunch of engineering nerds, and suddenly people talked about us working with whatever secret organization to take over this world. And we had a very hard time handling that in the beginning.
It reminds me a lot of, if you've seen, there's a guy, and his name's Peter Pan. He's written like the history of Bitcoin from the cypherpunks all the way up to current day. And at different times, there was fights back and forth with the government, thinking these group of people were going to stop them, like taking over the world. And they were talking about encryption systems, and like they were going to legalize encryption for certain amounts of groups of people. There are other things, but it sounds like similar. The people that were making it didn't realize what they were making. And then when they did realize, they were all the cypherpunks, and they were against the government, against the people trying to censor what they were doing. And they had to fight to even allow you to encrypt your own personal data. Don't know how relevant that is, but that's kind of, it feels similar.
Yeah, and actually some of them were also in the against trusted computing area. And I then worked on this a little bit. So I then left IBM, went to university, but then also started working on privacy. So then I got de-evilized and was accepted as a also good person. So that was essentially the next topic, work on privacy protocols. Then I left university again, went back to industry and Philips research, still working a bit on privacy, but also then more wireless Internet of Things kind of stuff. Did some of security for the Zigbee protocol, which still is around, but probably not that popular anymore. Via Zigbee got introduced to smart metering, since smart meter manufacturers wanted to use that. That dragged me into critical infrastructure security. So that was actually the last thing I did before coming back to the decentralized world. That I worked a lot with power providers, securing electricity grids, smart meters as a beginning, but everything that's behind, they want to connect everything to the internet, which is a very, very scary thing if you see the details. Also co-founded a startup in there, but at some point I left it. And then, now I'm back in the decentralized world, first as an advisor for Chainspace, and now pretty much full-time with Vega.
Sweet, you've had real history in security, centralized systems, and the blockchain industry. And what made you decide that it was worth working with Vega? You said you were with Chainspace, but you hadn't done anything with the derivatives protocol before, or anything in that area. You've known a lot about blockchain systems, so.
No, I haven't done anything with derivatives. So there were two things that I liked about Vega. So one, even though I still wouldn't say I really understand derivatives. So if anybody asks a question on there, I discreetly point to other people that know more. But I've also seen a lot of blockchain protocols where you ask why on earth do they do this on a blockchain? And Vega was one of the projects where I said, this actually does make sense to do it on there. So when I started first looking at the area again, was a time when there was a lot of money. So people were just saying, oh, I do this on blockchain, and then they were showered on money. So I actually first saw this in the energy market, that people said we can secure smart meters with blockchain. We all know hardware is insecure, so blockchain, so it was sort of the magic bullet that solves everything. And derivatives is one of the areas where this actually makes sense to build distributed system that offers this service, that democratizes this technology. So even though I don't understand a lot about derivatives, but the decentralized finance, this makes a lot of sense to me. And if it works, it can really change a lot of good things. And the other thing is, as opposed to other projects, this actually does come with interesting challenges that you need to solve on a blockchain level. I think most projects, you can glue them on any blockchain and they don't need to worry what the blockchain does, because as long as it offers a blockchain, they're fine. We do have things like very low latency times that we need. We have somewhat higher security requirements. The fairness thing that you probably will ask me about later. So we have a lot of actual research and development topics that need to be solved on a blockchain level, which also makes it interesting for researcher. So there's a lot of projects where I could be on, but I wouldn't contribute much because I work only on the application layer, and in Vega I can really contribute. And the other thing, so I met some of the management in Vega in Chainspace, and it's actually good management, and you see this. It's a good atmosphere, it's a positive atmosphere, and I really like the way Vega is managed. And there's a lot of small details, so don't want to brag too much about it since this is a Vega call, but you see in the details that the management really cares not only about Vega, but about every single person working in there. And this is something probably somebody who only worked for Vega will not understand Dilbert cartoons. And that's a very, very nice thing about it.
Yeah, I agree. And we kind of need to convince the community that Vega people do really care about the project. And we're doing all we can to to try and bring this experimental thing out there. But yeah, let's move forwards because I have many, many questions for you. And I want to keep it under an hour. So last week we talked to the smart contracts team. And this week we've got you, one of the original members of the research team and one of our most knowledgeable people on blockchain architecture. Could you tell us a bit about what you do in your day-to-day job and how does your research impact the overall protocol?
It's actually varying. So right now, the most activity actually goes into really getting the final implementation details right so that we can start mainnet. So I'm much more in the spec writing area than in research. We are talking a lot to the validators, so that's also since they run the blockchain and I'm sort of doing the future changes to the blockchain. So there's contact on there. What do they need? What do they feel comfortable with in operational security? If they do this, how does that impact the blockchain? So one concrete thing is now they want support for hardware security modules, but some of them don't have the money to buy a really expensive one, and the cheap hardware security modules are sort of slow. So analyzing what does it mean and how can we integrate this that we can at that level of security without slowing down Vega. So right now it's relatively small concrete questions like that. Also the whole validator reward scheme. I did the first throw on this a while ago that we wrote a couple of blog posts about. Now it needs actually real validators that gets real rewards. So that also is a lot of steep learning curve on both sides. And what does it mean and what do we need to change? And otherwise, the long-term work is new features that we need. So fairness was one, but other things generally prevent financial fraud happening on Vega. Sharding will come at some point. Speeding up Vega, so everything that essentially happens down in the plumbing department, that if I do my job right, you will never see it actually happened. And to make sure that the protocol can then work smoothly.
Great answer. And yeah, keep working. Behind the scenes or up front. We want to make sure that everything works smoothly. And yeah, so to go a bit deeper on the research, you wrote a paper on ensuring fairness in Vega Protocol, if I recall correctly. Why do you care about fairness? And could you perhaps give us a little summary of your research to tell us why we should care?
Well, I generally cared about that actually since a very long time, since I started in the area and realized everything there is highly unfair. So if you have Byzantine agreement, the only requirement is everybody agrees on something. It doesn't mean that a lot of people actually wanted that to be agreed on. So it had no majority thing in there. For Vega, it actually got a very concrete problem since we have a financial product. And already in centralized exchanges, we see people that invest millions of dollars to be a little bit faster than other guys. And they can turn this into real financial advantage, which you can use different verbs how to call it. So but let's say they essentially impose a tax on all other traders, which then goes into their topic. So one simple example is if I sell my stock for $99 and you make a buy order for $100, if somebody who's faster than both of us sees it, they can buy mine for $99, sell it to you for $100 and keep the dollar, which would otherwise be somewhere split between us. So someone essentially taxed us for that money. In a centralized exchange, this is already happening. Some people start on countermeasures. Some exchanges actually go the other way around and just rent off the fastest service so they get some part of the money rather than everything going to the people that do this. On a blockchain, this front running is much easier since a validator sees a transaction much longer before it actually ends up in the chain. And validators can thus reorder much easier than you can on a centralized exchange. So unfairness is actually a problem that is bigger in distributed systems and in centralized ones. And on Ethereum, there are already concrete numbers on the damage, and it's 3-digit millions of dollars that are stolen already, taxed already by people that just see a transaction that would make money, offer more gas, get before it, and then get that money rather than the guy who originally came up with that. If we want to convince people to come over from centralized platforms and start serious trading on Vega, we need to avoid this kind of transaction tax. And that is where the Fairness Protocol comes in. So what it's doing is to make sure that transactions are essentially executed roughly in the order that they come in. So if you see my transaction and act on it, then it's very difficult to get your transaction before mine. The challenge in there is we can actually prove that in the form that we wanted, it's impossible. So we needed some workarounds to make sure we can actually make this possible. And that's something you also see a lot in decentralized systems. You have a lot of impossibility results. Even agreement itself has been proven to be impossible. So the fun thing is then to find some way how you can get around this impossibility result without breaking anything else. And so this is what our Fairness Protocol does. And then the other challenge is we are running on Tendermint, and we don't want to open up Tendermint and change everything, because that gets us into a nightmare of every time then Tendermint does need to make an update. We need to see where does it affect us. We can't just use their binaries, and just generally don't like everybody making a fork and changing their code on this. I like a lot of people working on the same consensus layer. So the other challenge is, which I'm currently also working on, is make sure this works without having to modify Tendermint, that it's sort of blockchain agnostic and can be plugged on and doesn't need to care how the underlying blockchain works.
Yeah, there was a lot of stuff covered there. And yeah, the comments about MEV is really, it's quite a big problem with Ethereum. I think a bigger problem than some people actually realized. You can have sandwich attacks, you can have arbitrage attacks, you can have there's a couple of different types. There's loads of different ways for miners to extract, not miners, for people with flashbots to extract value by even like sending transactions directly to miners and going through the relay straight to it. I've been looking into it a bit recently, but I'm nowhere near technical enough to be able to create my own flashbot or do any of that kind of thing. I'm not sure I'd want to. It seems quite immoral, but yeah, it's quite an issue, and I that's one thing that like I'm very glad that we're working on solving with Vega. And yeah, your paper's good. I think people should check it out. If you haven't read it yet, do check it out on the Vega website. You also said something about Tendermint and maintaining two different, making sure we don't fork our own copy of Tendermint and then start adding our own things to make sure it complies with fairness. How difficult have you found it trying to make Tendermint comply with the fairness research that you put together and the way you said we should implement it?
I actually did have to, so there's a new version of the protocol coming out. Since we ran a little bit, I wouldn't call it a wall, but we had 2 points where we would have to modify Tendermint. One is the mempool management, that you can't tell Tendermint, this is the order in which I want these transactions to be scheduled, and it does. So you can put things into the mempool, and then the mempool does whatever it pleases. And the other thing is we would have needed a new block validity function. And in my ideal world, and I talked to this with the Tendermint people a while ago, is that the consensus layer would be very modular, that you can just plug out different components and replace them by something else, like also the gossip protocol, plug in our own, the block validity protocol, the mempool. The Tendermint essentially would be a big kit of Lego sets, and you can just take any stone, replace it with another one that suits your needs, and the rest still works. This is on the roadmap, but right now it's a more monolithic system. So right now, if you want to change the functionality of something, some component, we would have to actually change the Tendermint code, which at this point is something that we want to avoid and focus on getting all the other things to run. So actually I did have to then redesign the protocol to make it work with Tendermint without having to do these changes. And I'm still going through the last proofs to make sure that actually works, but it seems that it's now actually working, so we can integrate into Tendermint without having to change it.
Yeah, on that topic, have you ever had to change some theoretical research that you put together because of technical limitations with the protocol, with the blockchain systems that we have available today? And if so, is it usually a thing that's like a limitation with current blockchain systems, or is it like a systematic issue and then you're not able to fix it no matter what, and you just have to change your research because things work in theory but not in practice?
I mean, that was actually a primary example where I needed to change something. We did need to change something on the validator reward scheme, but that was actually more the economics that hit us than the Tendermint implementation. I think generally for most blockchains, I would like more modularity, that you can make small changes more easily. To go a step back, so blockchains, as I said, there's a lot of impossibility results. So every blockchain is essentially, or every consensus layer is a huge bag of compromises. So Tendermint, for example, has a gossip protocol that allows it to scale up to more validators. But if I run with a relatively small set of validators, then I don't need the gossip layers. So I should just be able to leave it out and then say I don't need 500 validators, leave that part out and give me the one that's optimized for 10. We are optimizing for latency, which also wasn't necessarily on the Tendermint mind. I think we are the most ambitious protocol in terms of latency. Usually people care about throughput. That's also something they made a choice. That choice is now baked in, and it's very hard to say we would like a slightly different choice. Can we do it like this? So this is why I'm so eager to see more modularity, so that if people made a choice for a particular reason, that you can say, but I need a slightly different optimization and I'm willing to pay the price somewhere else. So I want lower latency, I'm willing to tolerate fewer validators, or the other way around, that you can just build that in. So this is my main problem with essentially most implementations out there, that everybody has a compromise somewhere and you have to, but I want to choose the compromises and I want a Lego set where I can decide this is a compromise I want to take, but this is a non-negotiables for me, where I definitively I pay somewhere else and want to optimize here.
Yeah, on that, would you say Tendermint's your favorite set of compromises, or have you seen other places, other blockchains that have done it, in your opinion, a better way?
I wouldn't actually ask it this way. So my main problem with blockchain, or the main thing with blockchain implementations, the consensus algorithm itself is actually usually relatively simple. So when I implemented my first one, and I'm not a good coder, and yes, you shouldn't run this code on anything you care about, but I needed about 3 weeks to write my consensus protocol. The hard part is all the infrastructure you need around this. So most protocols assume, for example, eventual message delivery. You don't have that on the internet, messages get lost. So you need an entire layer in pretty much every consensus protocol that reliably resends messages, but doesn't allow for buffer overflow if they never arrive. So there's a lot of tiny details in the infrastructure that you need to take care of, that if you build your own blockchain, you usually don't have the capacity. So in this sense, the thing I like about Tendermint is it's a very big community. So it's a good protocol, but more importantly for me, it's a big community that builds a whole framework around it. And what I would like to see is being able to use this framework, that if I say I have slightly different priorities, I don't need to reprogram everything, but I can take the Tendermint framework, but change the things where I set different priorities without needing to worry about updates and other things. There's a couple of blockchain projects that may have done choices that are better suited for us, but they don't have this big community support. And I also don't like the idea that everybody who has a good protocol idea immediately starts to get VC money and builds their own blockchain, rather than saying, this is a good idea, why don't we make this available to a couple of big blockchain infrastructure projects.
Yeah, I completely understand that. And as big infrastructure projects go, blockchain projects, Tendermint is one of the most widely supported and one of the best, as far as I know, to start creating on. It's got a really big community. I think that's a good taste into a lot of the research you've been doing whilst at Vega. What else are you up to in like personal level? Are you doing any other kind of research other than your work at Vega? And if not you, what are the research team up to more generally?
So the research team more generally, so the bigger part of the team is actually working on the financial services side, risk models, all the stuff that I don't understand. So it's amazing work. I occasionally listen to talks given by, say, applicants and see the discussions, but it's nothing that I should comment on because otherwise I just look stupid. So I'm still working a little bit on more optimizations and flexibilization of the blockchain. So one other work I have on the site is getting rid of extending the staking model to build in more property-based things. So right now, if you're a validator, your weight is just determined by the stake. And I want to also build in some, say, geography that you say something we had in Bitcoin that now luckily stopped, that if every validator sits in China, then automatically validators in China are weighted down. So in addition to the stake you represent, you get some diversity over legislations. So this is something I'm working on to try and get diversity and generally more property-based models into the whole staking model. And otherwise, so when I did my PhD, I actually had a very different approach to what most protocols do now. So most protocols, including Tendermint, have a slight timing-based approach. So the safety doesn't depend on timing, but if the timing goes wrong, the protocol can get very slow. What I used to work on is a fully asynchronous, so no timing assumption whatsoever, which is a bit slower in normal case, but much more flexible and adaptive if things go wrong. So I'm still looking, can we combine this, and why did this approach not take off? What do we need to change for this to actually be a viable approach, since it has some properties that we now miss? It also was leaderless, which makes it much harder to front run. Or to make a denial of service attack. So that stuff I would like to do on the side, but right now the things that really need to be done and that are burning for getting mainnet off the road is a little bit dominating all of that.
Yeah.
So right now there's not a lot of time for pet projects.
Yeah. Do you think post mainnet you'll have a bit more time, or do you have another big project lined up?
I don't know. I mean, our first mainnet will be restricted mainnet, which is run by the real validators, but is still not feature complete. So that will probably still be a lot of work that needs to be done until we can allow trading. I would like to make sure that I can take, say, 1 day a week off for the more long-term things. And some of them, like also thinking now about sharding, we will need it eventually. And if you start thinking about these things a week before we need it, that's not how research works, right? So you need to think a bit more long-term, be allowed to run down wrong avenues. go to strange
Yeah,
conferences
yeah.
and just get weird ideas. So that it should run on the side. I'm just right now a little bit behind on my to-do list, and then it feels bad to have pet projects when you see your to-do list growing and people asking you on
Yeah,
Zoom when will you finish that?
Yeah, I can really relate to that, especially with everything we have going on right now. But it's fun. It's all fun, and there'll be time in the future to work on those pet projects. So let's move away from the blockchain side of things. Tell us something interesting about you. Give us an interesting fact. It can be that you used to be in a circus, or that you play the piano every night, or that you like surfing.
I don't know if I would like surfing. I did try stand-up paddling, but probably broke the record in falling down from it and managing to get up again. So people did say it showed a lot of stamina for trying so hard, but I never actually managed to stand on it very long. Circus? No, I never worked on a circus. I have friends who worked in a circus. Actually,
no, we want facts about you.
The friends don't count.
Yes.
Yeah, somehow I feel a little bit boring since COVID started. So not a lot of fun things going on. So one fun fact, but I probably overused it already a lot, is that my legal status here in Switzerland is to be a concubine, which people in Switzerland find probably normal, but people outside usually find it rather bizarre.
Wait, so can you explain this a little bit more?
Well, just fun wording. So in Switzerland, the an unmarried partner is called a concubine, and if you're living together, it's actually called concubinat. And
that's very normal.
My permit here is linked to my girlfriend, so on my permit it actually does say concubine too. So I can actually show my permission, and it says I'm allowed to be here because I'm a concubine.
That's a nice fact. Very interesting.
It's a fun alternative career, right? If the whole blockchain thing doesn't work, I can always work as a concubine.
Yeah, that's I hear very lucrative industry these days. Sweet.
Well, not in my age anymore, I guess.
I think you could command a good amount of attention. But we hope, luckily, we don't have to test that because we've got you here with us right now. So is there anything you would like to ask me? Or if not, this is the end.
Well, yeah, but probably offline. So
okay, well, you can ask me in the Zoom room because we have to hop off to the next Zoom room in case anyone from the audience would like to join us afterwards. We have no audience questions today. So yeah, this is it for the Fairground Jam. We've learned a lot about your research, and as always, we'll upload this on YouTube shortly after, so you can watch it back, and you can, yeah, for anyone who didn't catch it today, they can also find the video and see the amazing concubine-related things you've been talking about today, and your fantastic research. So yeah, thank you once again for attending. Thank you everyone for coming, and we'll see you in the Zoom room. Until next Thursday. Bye-bye.
Bye.